Hello everyone, we are Group 13 and our final project is to analyze the high-speed railway's influence on the housing price in mainland China. Chinese government put a lot of effort on the high-speed railway construction, and we suppose the high-speed railway can improve the GDP development. Specifically, we want to analyze the influence of high-speed railway on housing price, since we pay a lot of attention on the value corresponding parts of housing price. We can use both social science methods and machine learning methods for this task. The former is more explainable while it requires more human effort. The latter is more convenient and accurate while acts like a black box experiment. We want to compare both two methods and improve the current research design after the comparison. Comparing with the simplest linear regression solution, we will introduce social science solution and advanced machine learning solution. Both of them can provide deeper insights. Based on the DMAIC framework, we will in detail expand our idea. Firstly, this project is to analyze the high-speed railway influence on housing price. In the traditional statistics and econometry field, we are able to calculate housing price to some designed variables. However, such methods require very strict historic data. In our project, we strengthen our abilities to cope with the digital era, and we cooperate with each other from different backgrounds to improve the accuracy of predicting the housing price by using the new technologies in the AI field. We first collect relevant data about high-speed railway condition, housing price, and related information of cities in mainland China. Linear regression model is the baseline. Actually, we use the fixed effect model to get the baseline regression and a generalized method of moments estimation of dynamic panel data models as the robustness check. For social science solution, we examine the relationship between the high-speed railway development and housing price growth in China. For machine learning solution, we transfer the problem into a house price predicting task and analyze the feature importance and explainability of high-speed railway specifically. However, there are some limitations if we use the approach of the regression model to predict the housing price. On the one hand, some omitted variables always exist. We can't find all variables, including blind information and unquantifiable information. These external confounding factors that regression models cannot portray make it difficult to analyze the relationship between the past housing behavior and future housing price. On the other hand, it is very difficult to meet the requirement of conditions to conduct a causal inference all the time. So it is very necessary to use the emerging information technologies such as AI or big data to improve the robustness of housing price prediction model. In social science field, more qualitative research approaches such as case study can be used to provide more insights to the traditional regression model, and also we can have more heterogenetic studies, like we introduce the regional labels to help the prediction.
For machine learning side, we used more powerful models to help the prediction and achieve better predicting results than the linear regression one.
Here are some results of analysis for SVR method. Firstly, SVR method with a linear kernel can give a more balanced importance to features than linear regression. Weight given by SVR method can reflect true contribution of certain given features, while linear method will give very large weight to the variable that is most correlated to the task, which is a winner-takes-all situation. But this is not good for explaining the importance of given features. Moreover, applying some nonlinear kernels like RBF can gain better performance owing to a nonlinear decision surface designed in this task.
For the gradient boosting method, we find that in general, the most influential factors are the total loans of the city, which is quite reasonable because most of the commercial loans in our country went into the real estate area. Moreover, although high-speed railway-related features play a relatively small role, they account more than the existence of the airport, which should be taken into consideration by the government during infrastructure construction. We also calculated the average Sharpe value for all features we use and also the individual level Sharpe values for each city. As we know, the Sharpe value can measure how a feature increase or decrease the prediction comparing to the average level. From the result, we surprisingly found that high-speed railway has very little Sharpe values, which means that comparing to other more dominant features such as total loan and year, the high-speed railway has very limited impact on the price of the house for each city.
To control the improvements, we should first ensure the input data are cleaned and standardized. Also, if there are new data coming in, we should train the whole dataset again to ensure the effectiveness. Then, as we are using prior knowledge to enhance the prediction, we should monitor their correlation with the task. In conclusion, we find both social science and machine learning can help our analysis. For social science, we used quantitative research and more heterogeneity studies to help achieve this goal. And for machine learning, the more powerful models can better approach the true effects and reveal more instructive facts. This is the end. Thank you.